chemistry. In this lesson, you're going to be introduced to chemical equations, and you're going to learn the skill of balancing chemical equations. So a chemical equation is the centerpiece of chemistry. It states the elements and compounds that are put into a chemical reaction and points to the elements and compounds that will be produced by the chemical reaction. So you see an example of a chemical equation down below. To the left of the arrow are the chemicals put into the reaction, and they're called the reactants. To the right of the arrow are the chemicals produced by the reaction, and they're called the products. So during a chemical reaction, atoms cannot be created or destroyed. This principle is known as conservation of mass. On the left side of this equation, we have two vanadium atoms. On the right side of the equation, we have one vanadium atom. So if we were to believe this is a complete chemical equation, one of those vanadium atoms must have disappeared somehow, and that's not possible. So we have to have, in order for this to be a usable chemical reaction, we have to have the same number of vanadium on the left as on the right, the same number of oxygen on the left as on the right, the same number of hydrogen atoms on the left as on the right, and the same number of chlorine atoms on the left as on the right. For this to be a chemical equation we can use, there must be the same number of atoms of each element on the reactant side and on the product side. The process of equalizing the numbers of atoms is called balancing the equation. So we're going to learn two methods for balancing a chemical equation. So an equation must be balanced before it can be used in chemistry. The first method is called the box method. This is a good method for beginners. It's a good method, it just takes a lot of space on the page to do it, but it is a good method to get there. So what you simply are going to do is take each of the atoms and break them out as individual letters. So you have two vanadium on the left, so that's V and V. You have 5 oxygens there, so you see 5 O's. For hydrogen and chlorine, you have one of each. Then over on the right side, you have 1 vanadium, 1 oxygen, and 3 chlorines. And then for water, you have 2 hydrogens and 1 oxygen. So the object of the game is to pick an element to balance, and you can pick any element you want, although there's certain conditions here. And what you do is you add boxes to the side where that element has the least number. Okay? Now, one thing you want to do is avoid elements that appear more than once on the same side of the arrow. So you see oxygen appears in VOCl3. It also appears in H2O. So you want to avoid oxygen, save that for last. You also want to avoid pure elements. So oxygen is another good example, although you don't see it in this particular equation. But O2 oftentimes appears in chemical equations by itself. It's a pure element. It's not a compound with something else. So you want to avoid those and save those until the end as well. Okay, and as you gain experience with these, you'll see why. Okay, so what are we going to begin with? I think we're going to begin with vanadium. So we have 2 on the left and 1 on the right. So we're going to add 1 to the right. Now you can't just add the V. You have to add everything that's in that compound. So we have to add an entire box of V, O, and 3 Cl's in it. But now if you look, you have 2 vanadium on the left of the arrow and 2 on the right. Okay, so vanadium is in balance, so we move on to something else. So what else can we balance next? Again, we're going to stay away from oxygen. But chlorine, you have 1 on the left side of the arrow and 6 on the right side. That means you're going to need to add 5 more boxes for a total of 6 on the left side of the arrow. So we're going to go ahead and do that. So there's 1, 2, 3, 4, 5 more boxes. So you have a total of 6 boxes on the left. So now you have 6 chlorines on the left side of the arrow and 6 chlorines on the right side of the arrow. You haven't changed the vanadium, so there's still 2 and 2, so that's still good. Now the next one we're going to go to is hydrogen. And you see that you have 6 on the left side of the arrow, the hydrogens, the H, and you have 2 on the right side of the arrow, where water is. So we're going to add 2 more boxes for a total of 6H. So there's 1, and there's a second one. So now V, Cl, and H are all in balance. Okay? Now we said we were going to save O until the end, and something often happens when you do that, because it is the most complicated one to balance, is O ends up in balance at the end anyway. So you have 5 oxygen, 5 O's on the left, and if you count, you have 5 O's on the right. So everything is in balance. You have the same number of atoms of each element on the left as on the right. So now what you do is you place coefficients in front of each of these compounds, and that's going to balance the equation. So you have one box where you see V2O5, so you're going to put a 1 there. You have 6 boxes where you see HCl, so you'll put a 6 in front of that. You see two boxes underneath VOCl3, you put a 2 in front of that, and then you see 3 boxes under H2O, you put a 3 in front of that, and that's a balanced equation. Okay, so let's be sure this is in balance and we understand why. So over on the left you have 1 in front of the V2O5. That means you have 1 V2, that means you have 2 atoms of vanadium, V. And if you go over to the right side, you have a 2 in front of VOCl3. That means you have 2 atoms of V. So 2 on the left, 2 on the right. Now let's skip the O for right now. Let's go to H. You have 6 H on the left. If you go over to the right, you have 3 water molecules. That's 3 times 2 hydrogen atoms. That's a total of 6 hydrogen atoms on the right. So 6 on the left, 6 on the right. Chlorine. You have 6. Now that 6 doesn't just apply to the hydrogen over on the left side, it applies to the chlorine as well. It's distributed like distributing in a math equation. You're multiplying every element that's in there by that number. So you have 6 chlorines on the left of the arrow, and you have 2 times 3 chlorines on the right side of the arrow. So the coefficient of 2, and each of those molecules has 3 chlorines, so 2 times 3 is 6 chlorines. So 6 and 6 balances. And then the oxygen, you have 5 on the left. If you go over to the right, you have 2 times everything that's in VOCl3. So it's 2 times O. So that's 2 oxygen. And over at water, you have 3 times O. So 2 times O plus 3 times O is 5 O's. So you have 5 O's on the left and 5 O's on the right. So that is a balanced equation. And now you can use it for chemical analysis. Now we're going to see a second method. This is really a method you want to eventually get used to doing because it just takes less space, and it's just the standard way of balancing an equation, or you call it the atom counting method. You're going to count atoms. So what you do is you count how many vanadiums on the left. You have 2 atoms over there, and on the right you have 1 atom. Oxygen. On the left you have 5, and on the right you have 1 in VOCl3 and you have 1 in H2O. So that's a total of 2 on the right. For hydrogen, you have 1 on the left, and you have 2 on the right, H2, that's 2 atoms of oxygen. And for chlorine, you have 1 on the left, and you have 3 on the right. So nothing there is in balance. Again, you can pick whatever you want. We're going to just go ahead and do it in the same order as we did the last one. So we're going to go with V first. So we're going to put a coefficient of 2 up above the VOCl3. So now you have 2 vanadium. So you're going to cancel out that 1 and turn it into a 2. So now the vanadiums are in balance. 2 on the left, 2 on the right. Okay, next we're going to go to chlorine. So now you have 6 chlorine. So we actually have to go ahead before we do anything else. You have 2 VOCl3. So you have 2 vanadiums. You have 2 oxygens. And you have 2 times 3 or 6 chlorines. So you go ahead and change everything that's a part of that compound. You multiply it all by 2. Okay, now we're going to focus on the chlorine. So you have 6 chlorines on the right. So over on the left you need 6 chlorines. So we're going to put a 6 up there. So now you have 6 chlorines on the left, and you also have 6 hydrogens on the left. So we're going to change the hydrogens to 6 and change the chlorines to 6. Okay, so now chlorine is in balance and vanadium is in balance. Okay, now we're going to do the hydrogen. We have 6 hydrogen on the left. We have 2 on the right, so we're going to put a 3 up above the water. So now we have 3 times 2 hydrogen atoms. That's 6 hydrogen atoms on the right. So we're going to change that H to a 6. So now everything is in balance except oxygen. But when we count, we see that we have 5 oxygen on the left, and we have 2 oxygen in the VOCl3 and 3 oxygen in the H2O, so 2 plus 3 is 5. So you change that to a 5, and now everything is in balance. You have the same number of each element on the left as on the right, and so that is going to be our final equation. Although it's not the convention in books to put a coefficient of 1 in front of a compound where it is 1, I recommend you do it. I want you to see the relationship. I want you to see that you're going to need 6 molecules of HCl for every 1 molecule of V2O5. I want you to see that numeric relationship. So I recommend that you do that. Alright, so that takes care of this lesson on balancing chemical equations. You'll get a lot of practice on this in the coming weeks, and it's something that you'll need to know how to do throughout chemistry.